Hey everybody, what we're going to be talking about today is circles, but more specifically we're going to talk about sectors. Sectors are parts of circles, and in this case a sector is going to be this piece right here on the inside, or the pie piece. That's what's called a sector. Alright, so the sector is the actual pie piece. It's all of this space inside here. Okay? Now, some other things that we should know, some other terms that we should know, because all of these are going to be broken down and we're going to be looking at different aspects of our circle. So we know that that is our sector. We also have right here, this, on the outside here, that's going to be called our arc. Now, you can technically have a minor arc or you can have a major arc. So a minor arc is going to be a small piece that's less than 180 degrees. So it's going to be this part here. A major arc would be one if we were taking around the whole outside all of the way around. That would be considered a major arc. So depending on the information you're given, you might be talking about a major, you might be talking about a minor arc. Of course, we also have this line here. That is our radius, because anything that comes from the center of our circle to the outside of the circle is a radius. So we have one radius here, we also have another one going up this way. So we've got two radius pointed out in this particular diagram. The last thing that we have is called or last two things is this line here, and this is a chord, which we've talked about before. And again, a chord is a line that goes through a circle, but not through the center of the circle. So it could be anywhere in the circle, just as long as it does not pass through the center. And then the part below here, all of this down here on the inside, if I were to shade all that, that's called a segment. So we've got the segment, we've got the sector, of course we have the radius. We know diameters go all the way through the center. Two radiuses put together making a diameter. So that's a little bit of a review of the different parts of a circle and the different pieces that come into our circle. Now, let's do a little bit more review. The circumference of our circle is equal to the 2 pi r. Sorry about that. And the area of our circle that we've known for many, many years now is pi r squared. So what we're going to do is, since we're talking about sectors here, is we are going to find the length of the arc. So we're going to find the length of the arc, and we're going to find the area of the sector. And all we're going to do is we're going to use our circumference and our area formulas that we're already used to using, and we're just going to take a portion of it. And how do we determine that portion? Well, we determine it based on the measurement of theta. Theta is, let's do this. Theta is some measurement of our angle that subtends the arc. So remember, subtend is the angle that's opposite of the piece that you're talking about. So here we've got the theta is subtending the minor arc because it's opposite of the minor arc. Okay? So we use that angle and we modify our circumference and our area formula and just take a proportion of it, a fraction of this circle. So the length of the arc, so here we go. Got a lot of arrows on this drawing today. The length of our arc is going to be based on the measurement of theta divided by 360, so that's kind of taking a portion of the whole 360 of the circle, times 2 pi r. And then for the sector, here comes another arrow. The sector is based on our area, and the area of the sector, we'll write it as a subscript here. The area of the sector is going to be equal to, same thing, pi over 360 times theta over 360 times pi r squared. So all we're doing is we're taking a fraction of that. So let's look at an actual example and see how this works with the arc and the sector. Okay, so we have a sector has a radius of 12 centimeters and an angle of 65 degrees. So that means we've got 12 centimeters, and we have an angle of 65 degrees. What do we want to do first? We want to find the measure of the arc. We want to find this measurement right here. So we go back to the formula that I just mentioned. So for A, we're going to find the length of the arc, which is theta, our angle measurement, divided by 360 times 2 pi r. Plug in the values that we have. 65 divided by 360 times 2 pi times 12. Put that into our calculator and we get a nice approximate calculation of 13.6, and this unit measurement is centimeters. So the measure of the arc is 13.6 centimeters. Now we want to also find the area of this sector. So that means we're going to find all of this space inside here. So the area, again, uses a very similar formula, the modified formula, theta divided by 360 times pi r squared. Okay, so in this case, our area of the sector is going to be equal to 65 divided by 360 times pi times 12 squared. Again, with the magic of a calculator, actually it's not going to be equals. We're going to get an area of approximately, because I'm doing a little bit of rounding, so I put my approximate sign there, 81.7 centimeters squared. You can punch that into your calculator and you can confirm that I did do that and that I rounded properly. So that's what you're going to do with sectors. You know, based on the types of problems you're given, you might have to break up shapes and all that other kind of good stuff that we've done in the past. But that's how areas and arc lengths of sectors work out. Hope that helps, and we'll see you in the next video.